4.3, number 7 now. Two students are pushing a piano across the floor. So Kathy pushes, and Matt pushes too. Right. So this is where the FBD drawings can get confusing. Make sure you they are pushing, right? But the force with the arrow there actually shows up on the other side. Okay, so there will be two arrows. So this is gone here. So that. So two forces. What are they? 280, 340. This is 280. Okay. Fn. So it's 260 times 9.8. Okay. G is the same. So that's the 260. I rounded that, right? For sig digs, this would be 2,500, right? You understand that? So I have two sig digs here. Okay. Okay. So think about how we integrate A in this problem, 0.30. So it's accelerating forward, right? All our directions are forward. Right. I'm forgetting something on my FBD here. What am I forgetting? Forgetting FF. Okay. So let's find, well, we can't find FF yet because we don't know the coefficient yet. Oh, I see. I see. We know A, right? Okay, that's a neat problem. Okay, so it's the difference between these, it's when adding those three vectors together, and whatever the leftover is the total force acting on this. Now, we don't know FF, right? So you cannot use, well, I don't mean you cannot. I mean, you'll have to tweak F equal MA before you actually calculate anything. So that's what I mean. If you add these two together, right, 340 and 280, what is that? That's 2, 1, so 6, right? 6, yeah. Okay, so this is 620 newtons. if you enter this there, that won't work. That won't work for the simple reason that you didn't take care of FF, which is acting against. We have a way to find that because we know A, we know N. So what you'll do, you'll find F for the given mass. That piano is 260. We know A. We said it's 0.3. Just calculate that. Tell you an F. My number 260. 0.3, 0.3, because of the acceleration. So 78. Okay, so now that's making sense. So the actual force acting on the piano that's left over when friction and the people pushing is all combined together, I'm just left with 78. Right? So this has to be pushing this way with the leftover of 78 newtons pushing forward. This is a lot similar with to what we talked about this afternoon about the rolling resistance of the tire. This is exactly the same idea. Is two students pushed on the car, but the friction was not a friction, it was the rolling resistance of the tires that was pulling the car behind, resisting, basically. And you were left with a quite small force actually acting up on the car. Okay, 78, so 620, right? Like, look at it as, okay, this is big. I didn't want it big like that. Look at it as simply a balance, right? So this here has to be pushing down by 78, basically. Right? It's to be stronger than this one by 78. So if in here I have 620, so that means that on this side I have 78 less than this. To do that in my head, 80, hold on, 80, so 2, so 60, so 540, I have 2 less, so 538. That means that this is 538. 78, that doesn't work. 80, so it's more, sorry, 540. This is why you don't want to do that stuff. On your head, 620 minus 80, 60. So it's 540. I have 2 less, so 2 more. So this is correct. Okay. So that means FF is 542. Let us just check that. 437. Looking for the coefficient. Looking for the coefficient. Okay, so I'm not quite done. So mu equals FF over Fn. I'm looking for mu. I know FF. And Fn is 25, 48. Okay, 542. Point 21. Remember, coefficient is unitless. 21. Perfect. Okay. Next one. B. How long will it take the piano to stop moving? How long will it take the piano to stop moving? I'm going to pause it. I just want to think of it. Okay, so for B, it's in two parts. You have to find V final after pushing with such an acceleration. So you know the distance. You don't know the time. Right? But I need VF. Okay, so I'll pause again and I'll just keep going. Okay, so using the formulae of kinematics, this is the time I'm getting. 6:43. Oh yeah. Okay, I'm tired. Okay, I just that was not useful. Okay, right. So forget this part here. Look at this. Okay. So I found the velocity at which the piano is going at, and they stop pushing it. So I found V here, and I do know T. T is 6.2 seconds. Oh, yeah, are you serious? I use D at 6.2. Oh, yeah. I have to redo all of this. Okay, my apologies. Okay, so I'll pause this. I'll clean all of this. Okay. All right. So we know T. It takes 6.2 sec. We know A. We know VI. Looking for VF. Basically. So piano is at rest. They're pushing it for 6.2 sec with that acceleration. We want to find VF here so that when they stop pushing it, friction is going to decelerate it, and we want to find, and now we'll know VF, the new VF here will be 0. Okay, so this is what we want to do. So this is a bunch of kinematics here. Okay. Okay, I'm looking for this. So I go on page 37. I don't have the distance. So equation 2, VF, I know my A, I know my time, I know A. Okay, so I'll use equation 2. Okay, so the final equals AT. Okay, So this is 0.3 times 6.2. That gives me 6.2.3. Okay. This is the velocity final before they stop pushing. Okay, and I need now to find they're asking for how long. Okay, so it's t. So now I'm looking for t. Okay, so this here, I know vi, because now it's this velocity. Okay, that's a good problem. That's really smart. The person that wrote that knew what they were doing. We know vf, it's 0. We don't know a. We don't know d. We're missing a lot of stuff. What? How is it going to look? I'm not sure. Let's look at it. Right. So we'll be able to find A using F equal M. Right. So this is what we're going to go after. F equals MA. How are we going to find, how are we going to find force? Because what's acting from here to here is an FF. That's the only thing accelerating it negatively. So I need to use my formula. So move is FF or FN. What was move for this piano? 0.21. So 0.21 equals. Oh, do we know everything already? FF. Oh, it's the same things. It's this folks. It's 542. Is everything okay? That looks good. Yeah. So I don't need to do any of this. I know my F. 542. We know M. Piano is 260. That has to work. So what's the difference? So 542. 542. Okay. Do we have 208 anywhere here? Just go further. Do we have that number anywhere? Okay, so that's very neat. So what it means is the minute they stop pushing, it decelerates really quickly. This, like, so they push, it picks up speed, and the piano goes, it just stops very quickly because the acceleration is like 2 to 0.3. What's that? Yeah, to 0.3. What's that ratio? 20, like 8 times. It's going to slow down really quickly. Okay, that's a very good problem. My board is full. To the side. Looking for T. I know A. This here is this value. I don't have D. So I go in my formulae. Don't have D. Equation 2. Looking for time. I know A. I know VI. I know VF. That's beautiful. Beautiful. Okay, so equation 2. Final equals VI. This is equal. Plus ET. This is good. This is good. So I'm looking for time. So rearrange that. So VF minus VI divide by A. Fill that in. Here at the top, VF is 0 minus VI, which is 6. Now my acceleration is negative because it's accelerating negatively. So negative 208. And I'm done. So enter that. So it's 186. 6 divided by 0.9 twice 89. Okay, that's really fast. That's the big thing. That's right on it. Well done. Good stuff. Okay.